we're doing the distance formula. So if I have a horizontal line, horizontal means this way, like the horizon, or I have a vertical line going up and down, it's very easy to find the distance, and you don't actually have to use a formula. So here, it says find the distance of the line segments AB and CD. So AB, because it looks like the x-axis, we're only going to look at the x values. So here, 1 and 5. So first of all, you can do this with no math. You can just go, oh, I can count how many jumps. 1, 2, 3, 4. So that the length of this is 4. But if you want to use math, all you have to do is take the x values and go, okay, 5 subtract 1 equals 4. That's it. But what happens if you want to do 1 subtract 5? Well, that's equal to -4. So we can't have a negative distance here. So what we do is we go, oh, if it's going to be negative, we can't have that. So let's stick absolute values around what we're subtracting, and then the answer is always going to come out as positive. That's why we say the distance, when we subtract them, we have to have the absolute values because we don't want this to come out negative. So let's find the distance from C to D. So first we're just going to count the jumps. 1, 2, 3, 4, 5, 6, 7, 8. So the length or the distance between here and here is 8 units. Now if we wanted to use math, because this is the same as the y-axis, we're going to look at the y values. And if you remember, y always comes second. So I'm just going to go 5, subtract. Now be careful, this is -3, so it's 5 subtract -3. And when you have a negative and a negative, it becomes a positive, and so it's 8. Okay, and if you check on your calculator, you can go 5 subtract -3, and it's 8. But maybe you want to do it the other way. You want to go -3 minus 5. That's okay, that's just going to give you -8, so remember, always make it positive with absolute values. Okay, so that's easy if you have a horizontal line or a vertical line. Now let's look at if it's not horizontal or vertical. When it's on an angle, we call it an oblique line, so not horizontal and not vertical. Okay, so if you look at this, it's actually a right triangle here. This is a 90-degree angle. And so if I want to find this distance, I can find this easy because it's vertical, and I can find this easy if it's because it's horizontal. So I can just use the Pythagorean Theorem to find this distance. So the first thing I'm going to do is I'm going to go, oh, let's find this one. Because this is the same as the y-axis, I'm going to look at the y values, and I'm just going to go 7 subtract 3 equals 4. So I know this distance is 4. Now, because this one's horizontal, like the x-axis, I'm just going to look at the x values. And I'm lazy, so I'm going to hit the big number first. I'm going to go 8 subtract 5 equals 3. So that's 3 units. So now I just have a right angle triangle where it's 4, 3, and I don't know this. So remember, with the Pythagorean Theorem, the ones that are next to the right angle are the A's and B's. And the one that's across from the 90-degree angle, it's C. So this is C. We'll call this one A, call this B. Khaliwali. It doesn't matter if this is A or this is A. But lazim, this one must be C, across from the right angle. So here, I have C squared equals A squared plus B squared. We don't know C, but A is 3, and B is 4. So that's 9 plus 16. Which is 25. So I have C squared equals 25. To get rid of this square, I'm going to take square root because it's the opposite. So they sort of cancel each other out, and I'm left with C equals 5. So now I know the distance from here to here is 5 units using the Pythagorean Theorem. Well, we can put all this together to make another sort of formula, which is the distance formula. Oh, I'm coughing. I think I might have COVID. I don't. I'm just going. Every time you cough, you go, oh, am I sick? Okay, so this is exactly the same as the Pythagorean theorem. Here, really, I just had d squared equals x minus x squared plus y minus y squared. Okay, so the Pythagorean theorem is c equals a squared plus b squared. But in order to find what a is, I have to, remember here, we subtracted the two coordinates. So we have the y value, subtract the y value here. So I have to do the subtract first. That's why we have this subtract thing here going on. So I can't find b until I do the subtract. So really the distance formula is saying, please subtract the values, then square it. And at the end, we'd have to take that square root anyway, because really it's c squared. Okay, so this is exactly the same as the Pythagorean theorem. Okay, so let's look. So it says find the distance between these 2 points and round your answer to 1 decimal place. Okay, so I just look at my x values and I look at my y values and I subtract them. So these little 2's and 1's just really mean which point is going to be point 1 and point 2. Let's call this point, we'll call this point 2, and we'll call this point 1. So this is saying take the x value from point 2 and the y value from point 2 first. So what I'm going to do is I'm going to take these points. I'm just going to go 5 subtract 1, 6 subtract 2, square them, and put the square root over top of it. That's how I get the numbers in there. Okay, so I just go this one subtract this one subtract this, square them both, and then take the square root. So you can see that's 4, 16. And when I put that in my calculator, let's see what it is. The square root of 32. So it says 6, 5. So the 5 is big, so it rounds this 6 up to 7. So this is, it should be approximately 5.7. Okay, so let's look at these ones down here. So which one, I like doing the big numbers first because then I'm not going to have as many negatives. So let's do this one first and then that one after. So my distance is going to be, I subtract this and this. So 5 subtract 3, 7 subtract 4, and add them together. So I just go this subtract this subtract this, add them and put them together. So now 5 subtract 3 is 2, 7 subtract 4 is 3, and that squared is 4, 3 squared is 9, and that's square root of 13. And it says round to 1 decimal place, so let's put it in. 3.6, so it's approximately 3.6. Because the 0 is small, it doesn't change anything. Okay. Oh, there's negatives in both of them, so it doesn't matter which one we do first. So let's do this one first, because it's the same as that. So d equals, so I take the 2 subtract negative 3, so be careful. 2 subtract negative 3. Negative 7 subtract 5. And then we're going to square it. So 2 subtract 3, that's equal to 5, because the negatives change into a positive. I lose 7 and I lose 5, that means I lost 12. And then, take the square root, 25 plus 144, and then that would be 169, which is, the square root of 169 is 13. Be careful with this here, okay? If you don't use your brackets with a negative number when you square it, it will be wrong. So if I go negative 12 squared without the brackets, I get negative 144. But really what, you have to put brackets around this negative. So if you're going to use your calculator, go negative 12 squared. Oops. Okay. So be careful with that. So the distance between these 2 points is 13 units. Okay, this is a big question next. So it says, how would you verify if a triangle is a right angle triangle using the distance formula? So we want to know, is this a right angle triangle? So the only way I know of checking if it's a right angle triangle that's super easy is just using the Pythagorean theorem. We have to find this distance, find this distance, find this distance, and then plug it into the formula and see if it's true. So, well, we have to find the distances of these. Okay, so we need to go the line segment lengths. Okay, so let's do AB first. The line segment AB. Well, I don't have any points for them, but I can find them. X is -1 and Y is 1. Let's do all of them at the same time. B is 1 and up 1, 2, 3, 4. C is 1, 2, 1, 2, 3, and 1, 2, 3. Okay, so we have our points. Now, if I want to find the distance between A to B, or the length of that side, I'm just going to subtract them. So let's take this one, subtract this one. So I go 1, subtract -1 squared, 4 subtract 1 squared, and then I take the square root. Okay, 1 subtract -1 is 2, 4 subtract 1 is 3. Okay, so now I know. I'm gonna redraw it down here. So that's A, B, and C. And I don't know if it's a right angle triangle. So this side is root 13. Okay, so let's do BC. The length of BC is, let's do this subtract this. Okay, so now I go 1 subtract 3, 4 subtract 3. So 1 subtract 3 is -2. That's not a 2. 2. 4 subtract 3 is 1. 4 plus 1 equals root 5. So the distance from here to here, or the length, is root 5. Now let's find AC. So let's do this subtract this. So 3 subtract -1. That's not good. Let's try that again. 3 subtract -1. So 3 subtract -1. 3 subtract 1. Oh, you can't see my work. Let's go higher. Let me make it a little bit brighter. Oh, that's not brighter. There. Okay, so let's make it so you can see. So we're doing AC. So I said 3 subtract -1. Now I'm going to go 3 subtract 1. Then take the square root. So that's 4, 2, that's 16 plus 4 equals root 20. So that's root 20. So now we know, now we just have a normal triangle, and we're going to check to see if it's a right angle triangle. So the formula of the Pythagorean theorem is c squared equals a squared plus b squared. So across from the right angle, that is C. And then beside the right angle is A and B. So let's call that A and that B. Okay? So C is root 20. Oops, not plus. Equals. A is root 13. B is root 5. So the square of a square root cancels each other, kind of. So is 20 equal to 18? No. So then we know it's not a right triangle. So that's how we check to see if it's a right angle triangle, and it's not. Okay.